Hello, and welcome to Math Matters. I'm Ms. Matthews, and today we will be adding with fractions. Today's learning goal is to add fractions by seeing patterns with a variety of visual models. Also, as you are working today, you will have an opportunity to practice your Portrait of a Graduate skills for being a critical and creative thinker by creating solutions using a variety of representations. You will have an opportunity to reflect on this and our learning goal at the end of the lesson. Here are some optional materials you might want to have, but you do not need them to complete today's lesson. Our first fraction number sense routine is a choral count from the book Choral Counting and Counting Collections. Today we're going to start with a choral count. We're going to be counting by fourths. Are you ready? Say the numbers with me. Let's begin. 1/4, 2/4, 3/4. Let's pause there. What will we say next? You might have said 4/4 or 1, and those are both correct. We know that when we break our whole into 4 equal pieces, that the 4 equal pieces make up the whole. For example, in this length model, when we have 4 1/4 pieces, that is equal to the 1 whole. Knowing that, what numbers can we predict will come in these spots? Let's keep counting. After 4/4 is 5/4, 6/4, 7/4, 8/4. Let's pause there. What are you noticing about the fractions in this row? You might have noticed that the numerator, or the number on top, is greater than the denominator, or the number on the bottom. When this happens, we know that there are fractions that are greater than 1 whole. Sometimes we call these improper fractions, but I don't think there's anything improper about them. Is there another way that we can say the fractions in this row? See if the fraction bars can help you figure it out. Let's start with 5/4. What's another name for that? If we know that 4/4 is 1 whole, then 5/4 is equivalent or the same as 1 and 1/4. Now let's look at 6/4. What is equivalent to 6/4? That's right, 6/4 is equivalent to 1 and 2/4, or 1 1/2. We can also see that 2/4 is equal to 1/2. 7/4 is up next. What's another name for that one? You've got it. 7/4 is equivalent to 1 3/4. That brings us to 8/4. What did you predict would go here? Were you right? What is 8/4 equivalent to? We have another 4 1/4, which is another whole. So 8/4 is equivalent to 2 wholes. Let's keep counting. After 8/4 is 9/4, 10/4, 11/4, 12/4, 13/4, 14/4, 15/4, and 16/4. Looking at our fractions, what patterns do you notice? You might have noticed that going from left to right, we're adding 1/4 each time. So 1/4 plus 1/4 equals 2/4. And 2/4 plus 1/4 is 3/4. And 3/4 plus 1/4 is 4/4. and so on. We see that pattern repeating in each row. If we're adding 1/4 when we go from left to right, that means we subtract 1/4 when we go from right to left. That makes sense, since addition and subtraction are the opposite of each other. Let's see if this pattern works from right to left. 16/4 minus 1/4 is 15/4. 15/4 minus 1/4 is 14/4. And 14/4 minus 1/4 is 13/4. That pattern also repeats in each row. Another pattern that we can see is that we're adding 4/4 when we move down in our chart. For example, 1/4 plus 4/4 is 5/4. And 5/4 plus 4/4 is 9/4. And 9/4 plus 4/4 is 13/4. If we kept going, what would come next? You've got it, 17/4 would be next. We can see that same pattern in each column, and we could keep going if we wanted to. If we're adding 4/4 as we move down our chart, that means we are subtracting 4/4 as we move up our chart. Let's look. 16/4 minus 4/4 is 12/4. And 12/4 minus 4/4 is 8/4. And 8/4 minus 4/4 is 4/4. That pattern also repeats in each column. What do you notice happening to the fractions as we look at them going diagonally down, like this? Yes, they're increasing by 5/4 each time. 1/4 plus 5/4 is 6/4. And 6/4 plus 5/4 is 11/4. And 11/4 plus 5/4 is 16/4. If we continued that pattern, what would come next? You've got it, 21/4. There are so many patterns to find on our chart. Did you see the ones that we talked about? Or did you see some different ones? What other patterns are you noticing? Now let's move on to another fraction number sense routine. Next, we are going to do a number talk from Sherry Parrish and Ann Dominic's book, Number Talks, Fractions, Decimals, and Percentages. How can you solve 1/8 plus 7/8? You might have said the answer is 8/8 or 1 whole. We know that all of our pieces are eighths, so we can count them each individually by 1/8, like this. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. And we can find our answer that way. Or you might have also noticed that you only need one more eighth in the 7/8 to make a whole. And you might have thought about moving this 1/8 piece over to that missing space so that you can fill it in and get 8/8 or 1 whole. Take a moment to figure out how you might solve 7/8 plus 3/8. How can you use what you already know about 1/8 plus 7/8 equals 1 whole to help you solve this problem? One way to do this is to count up all of the eighths. Start with counting the 7/8 and then count on 8/8, 9/8, 10/8. So 7/8 plus 3/8 equals 10/8. Now let's think about this a little bit differently. How can we use what we know about 1/8 plus 7/8 equaling 1 whole to solve this problem? Well, I know I need one more eighth to make 1 whole right here. So I can take 1/8 from the 3/8 and just give it to the 7/8. I know I can do that because I'm not adding anything or taking anything away. I'm just moving things around a bit. So now I've renamed my problem. I'm solving for 8/8 or 1 whole plus 2/8. That equals 1 and 2/8, which is equivalent to the 10/8 that we got when we counted up before. Let's do that same kind of thinking for this next one. How can we use 1/8 plus 7/8 equals 1 whole to help us figure out 7/8 plus 7/8? Again, we see that we only need 1/8 to make 7/8 whole. So we can take 1/8 from the second 7/8 and give it to the first 7/8 to make 1 whole. Again, I'm not changing the amount that we have. I'm simply rearranging what we have to make it easier to think about. So now I have 8/8 or 1 whole plus 6/8, which is equal to 1 and 6/8. As you think about the learning goals for today, maybe there's something new you learned that you don't want to forget. Or maybe there is something that we talked about today that you still have questions about. Take a minute to record your reflections on today's lesson and save them for the next time that you are able to check in with your teacher. Today during our lesson, you also practiced your Portrait of a Graduate skills for being a critical and creative thinker by creating solutions using a variety of representations. Thank you for joining me for another episode of Math Matters for 3rd grade. My name is Ms. Matthews, and I hope you'll join us again tomorrow as we continue to learn more about fractions. Have a mathematical day!